from the company EME in southern France, and it is strongly temperature dependent. So at normal room temperature, around 20 degrees, I measured 2.0 dB. As the temperature higher, for example, in the last weeks, we had 40 degrees outside. I don't know what the noise figure is, maybe 3 dB or something like that. If you cool it down, you can easily do it by spray. You see that it's go far below 1.7, 1.6, but I don't know what the average noise figure is.
Moon noise.
The moon noise, what you see, it depends on which moon age you measure. And tomorrow I have a picture you can see, hopefully you can see it, we have to test it, but it works before. Yeah, you can see how the moon noise varies over moon age, over the 28 days. Even there is a tendency how it works, because you have more moon noise if you have full moon and less moon noise if you have new moon. But you answer your question, and in average it is 1.0 dB. Can be a little bit lower, can be a little bit higher. And the sun noise is roughly 10 dB.
We have a between us Iban. This is our friend Iban. I have to say that this is the designer of the 47 gigahertz VLNA, which everybody is using now. Not everybody. We have a Japanese Japan Alpha 8 Mike Yankee Charlie, but I am one of the lucky men which has at home also the Iban's LNA, and with the Iban's LNA I have a moon noise around 1 dB normally, and with the Japan Alpha 8 Mike Yankee Charlie I have a moon noise around 0.85 or something like this. I cannot to say what's the noise feature number, but I have to say that if I'm using this LNA, I have a higher level. But again, other problem is that if you are changing the elevation of the antenna, you have the lower attenuation in the atmosphere. And again, if you do this, if you do the test like this, you have to do it in the same time and maximally in 1 hour before you change something like the humidity, if you change the temperature, so that you have to be very quick. So, and this is what I was speaking about, to using 2 different feeds. I have a build, probably many of you see that on the YouTube. I have a 47 gigahertz transverter installed on the small aluminum table, which I am moving on the 3D printer engine with the step engine, and I'm moving from the focus to focus in one step, and I can measure both LNAs in one time. So that I have to say that seriously, if I measure 1 minute with this and move this another LNA, I have a different noise from the moon. With even I am in the same point to the same pointing position and same temperature and everything. So this is what you have to do. If you change everything, if you unscrew this, screwing this, that, it's completely changing. The 47 gigs is a little bit tricky, but it's very interesting. Yeah, Iban, come on, go ahead.
Okay. Yeah, about the moon noise, in my last results, I get over 1.6, 1.7 dB from the moon using a 1.5 meter fish. Yeah. The issue really not is the important, in my opinion, not is the amplifier, it's the antenna efficiency. The problem is to get more than 50% efficiency in 47. For 4 minutes, really is the key. Not because I am sure that the Japanese low noise amplifier is over 2 dBs or better, because we are using the same chip.
So if the measurement is right, and I believe that, I trust that what Stanek measured, the difference is 0.15 dB at that temperature. Because the difference cannot be much, because we both, or in both amplifiers, the same chip is used. You can do something a little bit with the bonding technique and calculation of the case and so on, and maybe this is a 0.15 dB, what Ivan's amplifier is better. But for me, and this has nothing to do with the absolute value Ivan measured with his dish, because if the value are true, then the efficiency of your dish might be much better than dish used from Senec and I use, L use or close use must be all better. But we will see when it starts transmitting. This is the key point.
Okay, but the efficiency is the same in reception and transmission. Then probably.
Yeah, but when you transmit, we can see that it is true. Yeah. So, but one last sentence is about that to answer your question. The difference of 0.15 is so small margin that all the other points I pointed out here are much bigger. So little bit misalignment of the antenna has much more effect than a little bit more or less noise.
I think one thing you have to understand about noise figure differences is on 47, sometimes you've got a one or two-way path loss through the atmosphere of maybe 4 dB loss, 2 dB at each end, so or more. So a 0.15 dB noise figure difference is very small compared to the loss in the atmosphere, which is of course adding to your noise figure. So it will, I think. The other question I had is on antenna efficiency and moon noise, because the classical understanding, by which I mean mine, is if you've got a 60% efficient antenna versus a 40% efficient antenna, that will reflect in different beam widths. Now, when you measure moon noise, you're looking at a spot generally, and if the temperature of that, if your antenna is seeing a little bit more or less of a hot spot, then is the antenna efficiency going to really cause much of a change in noise figure? Or is in fact the hot spot actually quite small from the modelling of the fact that the moon noise varies with position on the moon? Maybe that hot spot isn't that large, and so a bigger antenna will see more of it. Other questions there?
From the pictures from the Kiel University in Germany, you can see that the hot spot sometimes or most of the time is very small compared to the moon surface. So it could be, to give you a number, 10% or something like that, maximum 20%, but not more. And it is delayed by 4 days in the moon phase. So the hot spot of the moon is always behind from that what you can see, the visible moon, because it takes some time that the moon heats up.
This is why I was very much confused when I start to first measuring from the 47 gigahertz, because I start in a time when moon was, let's say, in first half, so that I had some level of the moon, and I was pointing to the moon and find that the curve was not so flat, it was a little bit more sharp. And this is the reason why, because the noise from the moon, which we are receiving, this is also the hot spot of the moon, where is the high temperature on the moon. So that I was pointing to the moon, and suddenly I had a peak and it's go down. And if I have a full moon, I'm going up. I have a peak, I'm going like this, I'm going again down. So this is depend of if you have a full moon, new moon, if you have the first half or if you have last half. It's very very tricky. So that if you want to measure something and if you want to have the result, everybody of us bought the infrared temperometer, so that we are measuring the infrared temperature in the point where we are pointing with the antenna also to the moon, and finding all those informations about to be sure what we are doing, like the humidity, temperature, the elevation, and so on. Very interesting result has the guys from Spain, I think also Jose, because they had a so high temperature and very, very low humidity, something like 20% humidity. And it helped too much for them with the reception of the signals via 47.
From low humidity, this is much more than he lose from other aspects. Yeah? So gain dish gain efficiency or whatever. So there's a low humidity you have in Spain. This helps much more because the normal, like Germany or France or Czech or so, we have always humidities very high normally. This was a warm summer, a little bit different, but never so low as you have, 20% or something. This never happened. And if you calculate with the VK3UM calculator, you see what Charlie pointed out is always 2 dB in average, 1.8, 2.21 each way. So you have always to calculate with 4 dB loss any transmission and reception. It's 4 dB. And if you can go down maybe with low relative humidity by 1 dB, you gain 1 dB. Where did you find something go 1 dB better? No, there's no way to find 1 dB. But with the atmospheric damp loss, this is easy to find. Yeah? That's one point.
Going back to your frequency offset. Just a second. Going back to your frequency offset problem, rather than hunt around, why not run multiple simultaneous decodes with slight frequency offsets? A little more computing power is a whole lot easier than all the work you do to get on 47 gig EME.
Yeah, the question was why not have multiple decodes happening at different frequencies all at the same time in WSJTX? I think you could, but the WSJTX team is a small team, and it is quite easy to think of things that would be nice to do, but it's a question of how much would it get used relative to the effort to put in. So we all got wish lists for things that we'd like to have done in the program. There is, I mean, it's doable with operator skill. You've got a minute to try different frequencies, and bear in mind, this is only happening when you are near the margin. You know, if you can find another dB, then it's all easy. You can use a 100 Hertz F-toll or more. It's the point where it becomes critical is when you're within, you know, a very small margin of the decodability. Most operators on 10, 24 gigs are not aware of any of these factors because generally the signal to noise is just that little bit higher. But on 47, you are struggling right at the limit, and this is where these things become quite critical.
Okay. Some more information about that. It's not really necessary to use WSJT. It's hard for me to explain in German. Because there is another program, a very old program on the market, I will say. It's made by the Russians. Its name is Microwave CW, MWCW. I made a test during the last months with this program with Sergey in Russia, and it works the same way. As Charlie pointed out, the report in Joe's program is always a little bit too good because due to the missing noise at the low end. And the best reports are received from all the people who can receive me are -14. This is the best report, but an average -15. So if you assume that there's really be too good, is this really be a good value, or is it less or more? What the missing noise makes a report better. I think it's really I think it's good. If you have 50, then you end up with 80. So the real value Joe's program measure is -80, let's say. And the report, the other programs, this is real CW in an endless turn. I transmitted 5 minutes, only both call signs, and Sergey could decode me after half the time. After 150 seconds, he could decode me. And the decoding level was 19.1, -19.1. So this is very close to what the real JT program measures. And even this is an example that is possible with other type of transmission too. It's not to the computer what we all use. Fixed can be done with CW too, but a little bit computer help is needed. Yeah.
One question. So I think that
let's say we finished what we know now. And probably in the future we will have more information about this the very interesting and funny job on 47 gigs. I am seriously looking forward very much for presentation which Manfred has tomorrow about the 47 gigahertz. And I hope, as I say on the beginning, I hope that somebody of you will follow us and we will find more people. We have a Jose, Echo Alpha 3 Hotel My Japan, he's here. He has a perfect setup for 47 gigs. And Hans is here. Where is the Hans? There is the Hans. Hey, okay. So we have a couple of the people which already spent a couple cents, a couple euro cents in this business, and we are trying to play with that. For myself, the good news is that thanks to IBAN, I have the new toy so that I can play with two different LNAs. I can do the more measurement, and I have to say that for the beginning, I was thinking about the switching on the 47 gigs, so that I have original Militech switch. How expensive it costs? $4,800 US, but this switch has a 0.25 dB attenuation for the switching between RX tags, so that you have almost 0.3 dB attenuation just only in the switch. And this is why I was designing the small, I call it meat plate, because it looks like a meat plate if I put it in the dish, and then tomorrow. Okay. So and I am moving 2 feeds. I have the same types of the feeds for the transmitting and the receiving, but I have only 2 watts RF in this time. It's seriously not enough for moon bouncing, but it's good for a start to play. And I'm changing the position of the feed for a transmission and the receiving. Now I will change the second wave with the EBAN's LNA, and I will play more with the reception without any wave right switch, because as I say, it's a 0.3 dB RAM. So if you have the LNA from EBAN, which is 1.6, 1.7, something like this.
Room temperature 1.8, but in exterior aging, the weight there will be 1.6.
So then, if I put the switch front of this, you have immediately 2 dB noise measure LNA. So this is what we play. I was testing also the Peltier cell, so that I was cooling down the temperature of LNA, but there is another problem. If you have a little bit higher air humidity, the water start to condensate inside, and you are damaging the LNA. So that it's so many the programs which I have to say that Sergey at W3 AW, he was the building the system for 76 gigs, where he has the LNA put in the small box, which is vacuumed and which is cooled to the minus 270 kelvins, 190 or 200, something like this. So and then he has calculated for 76 gigs will be enough the power 3 watts to have the open echo, because he has a 0.3 dB noise feature for 76 gigs. So, but it's a Sergey, so nobody from us can to repeat it now.
It would be very interesting if Stanek is able to switch the both LNAs in a very short time, and you can receive me to see what are the single reports, different single reports. This is the most important question for me at the moment. What happened? Yeah. Hans?
Yes, what I would like to suggest, and I have done that before, is to measure the noise received over the elevation. So you start at a 10 degrees elevation and measure noise up to 90-degree elevation. It tells you about the atmosphere you have, it tells you about the antenna temperature you have, and it tells you about the noise figure you have. And you can get a quite fast impression on your received performance by just measuring the noise level you will receive. That's a very easy measurement. It can be done in 2 to 3 minutes.
That's correct.
Yeah.
So it means that we have to more play like to transmit. So it's good for us because we have a problem with the power of 47 gigs, and we have a lot of things to do in the reception. So that's good news for us.
It's not zero.
Okay, guys, if no more questions, thank you very much for your attention. I hope that you find something interesting that my friends will present, and that we will a little bit more understand now what we are doing on the frequencies of 24 gigs now. So thanks very much. So that we have a restaurant book until the 22, and then we can follow in the lobby bar. There is the prepare another the barrel of the wood, the wood well, which we saw today how they produce, and so that we can taste it.